This is the homework helper for Chapter 2, Section 9 in the workbook, which is about equivalent fractions and mixed numbers. Okay, so as you can see, the questions in 1 through 6 are all asking you to do the same thing. So we'll model one with number 1, 2/9. And the directions for this question say to find a fraction equivalent to the given fraction. So as we talked about in class, usually when we think about equivalent fractions, we think about like reducing a fraction and making it smaller. But 2/9, you can't make any smaller. But what you can do is you can make it bigger. And the way you do that is you multiply the top, the numerator, and the bottom, the denominator, by the same number, any number you want. Now, as we talked about in class, usually the easy ones are 2, because that means you're simply doubling the fraction, and 10, because 10 simply means you're going to add some zeros. So let's say we want to double the fraction. Again, that means we're going to multiply both the top and the bottom, the numerator and the denominator, by 2. That's going to give me 4/18. That would be one possible answer here. There are many. Let's say you want to go with the easy one, the multiplying by 10. Well, all that's going to do is add a 0. So that's going to be 20/90, and that is also an equivalent fraction. Okay, let's take a look at number 7, a different set of questions. For 7 through 12, you're going to be doing the same thing, and that thing is to determine whether the fractions in each pair are equivalent. And you've got 8/10 and 12/15. So these are yes or no questions. Either you're going to say yes, they are equivalent, or no, they are not. What you're going to be trying to do here is to make these fractions somehow go to the same thing, become the same fraction. By making them smaller, by making them bigger, by making one smaller and one bigger, whatever combination to make that happen, if you can make them into the same fraction, they are equivalent. What I'm going to do here, because both these fractions, as you can see, can be reduced, is I'm actually going to reduce both of these fractions. With 8/10, I can take a 2 out of both 8 and 10. So I'm going to chop 2 out of that. And again, that means I'm doing it to both the numerator and denominator, and I get 4/5. Now with 12/15, I can chop 3 out of both of those. So that's what I'm going to do here, is I'm going to chop 3. And again, the reason I'm saying chop 3 here, instead of writing divide by 3, is because I'm doing it to both the numerator and the denominator. Technically, if I just wrote divide by 3, dividing a fraction by 3 would actually mean multiplying by 1/3. And that's not really what I'm doing. I'm taking 3 out of both the top and the bottom, which divide by 3 doesn't really do. All right, so I'm chopping the 3 out of there. 12 divided by 3 is 4. 15 divided by 3 is 5. As you can see, they both changed into 4/5, which means the answer here is yes. That's what we wanted. When the fractions turn into the same thing, they are equivalent. If they would somehow have been different things, they would no longer be equivalent. Okay, let's take a look at the next one, 13. We're supposed to, in this section, for 13 through 16, write as a mixed number. Alright, so per the directions you saw in class, what you want to do here is divide. You're going to do 21 divided by 8, top divided by bottom. And I'm going to see that 8 can go into 21 here 2 times. And of course, 2 times 8 is 16, and it would leave me 5, which is my remainder. So if we want to write this like old school, elementary school technique, we would write 2R5. 2 with a remainder of 5. That's the information I need to write my mixed number. There's 3 parts to the mixed number. You've got this big number in front, and then you've got a fraction. Well, that big number in front is the number we figured out with before the remainder, the 2. So that's going to be the whole number part of my mixed number. And then I got to write a little fraction here to go with it, and that's how I'm going to complete my mixed number. The remainder, 5, is actually going to be the numerator of the fractions, 5. And the denominator, well, that's probably the easiest of all. It stays exactly the same as it was before. So since it was 8 before, it's still 8. And that's 2 5/8. So 21/8 as a mixed number is 2 5/8. Now in 17 through 20, they're having us reverse the process, and they're going to have us write as an improper fraction. So for 17, you're going to take 8 2/3 and go back to something like this, as an improper fraction where the numerator is greater than the denominator. This is something you've been doing for a long time, and most students tend to be really good at. What you're going to do is take this denominator, multiply it by the whole number part, 3 times 8 is 24, and then add the numerator part, 26. And that's going to be the numerator of my improper fraction. And just like over here, the denominator is really easy. It stays the same. Since it said 3, it's still 3. 26/3. Mission accomplished. 8 2/3 as an improper fraction is 26/3. Okay, a couple story problems here. Number 21, Maria's desk is 33 3/4 inches long. We're supposed to write this as an improper fraction. So we're doing the same thing we did here in question number 17. And I'm going to use the exact same technique. All right, make sure you can do this here. Pretty easy. 4 times 33. Ooh, bigger multiplication there. We might have to think about that a little bit. Well, if you need to, we can break it down. 4 times 30 is 120. And 4 times 3 is 12. So that's got to be 132. Plus 3 is going to give me 135. So that's 135 over 4. Remember, the denominator stays the same. So her desk is 135/4 inches long.